Hello, my name is Bryan Calhoun. I am a solutions engineer with Volatus Drones, and I'm here to talk to you today about the FigSpec 60 payload system for the Matrice 350 RTK. It's a hyperspectral system that will allow you to capture hyperspectral data from a lot lower altitude when satellites are not available. The first thing that you should note is that there is some configuration you'll have to do. What we are showing on screen right now is the custom profile data you will have to put into the system to properly operate the camera. I'm not going to go through many things in detail, this included, because there's a lot to consider with this payload, but I want to show you each and every step so you get an idea. Customers of ours can always ask for training and assistance with their equipment, so we can show you all the aspects you'll have to consider when operating this equipment. Right now we are showing you a simple setup of the equipment, removing all of the covers from the hyperspectral and RGB spectrum cameras and also the port cover, and connecting to the ship, powering on the ship to activate the gimbal. The gimbal activation does not mean the payload is fully operational. There's also a power button for a microcomputer that sits within the payload that must be activated separately in order to get the payload to be fully operational. Along with this payload, there is also a cloth target that you should take with you into the field, like multispectral cameras, for example. There is certain reflectance corrections that will need to be done, and this panel needs to be captured with your data in order to do those corrections. So here's a quick look at that reflectance panel. Once you have your payload in place, your reflectance panel on the ground, in line for your data capture, you're pretty much ready to take off. We won't go over that aspect right now, but please keep in mind that training and licensing for legal operations of this equipment is something we can definitely assist our customers with. But let's focus on the payload for now. After we do our data capture, we'll have to bring the equipment back to our office. You can either keep it attached to the drone to do this next part, or also just attach a separate power cord. For this data extraction aspect of the process, we're just going to leave the payload attached to the drone, and we're hooking up our workstation to the equipment. First, we will attach a data cable so we can connect a keyboard, mouse, and also a memory stick. And then we will hook up a HDMI cable to the payload, which will connect to a monitor, pretty much creating our own little computer system. And in fact, this system runs on a modified version of the Windows 10 operating system. So once you actually get to this point, people who use Windows will be very familiar with how to get the data. Removing the data from the payload is not a difficult process, but it is a time-consuming one. You have to find the location on the hard drive. First, it's the main hard drive, and it will be a C drive location for this payload. And then after you go to the C drive, you'll go to FigSpec, and then File, and then you'll go to the file created for your mission. Every mission has a file created for it, so it should be easy enough for you to find a specific mission based off of the time and date stamp created every time you start recording with your FigSpec payload. Now that we have the file, we can remove our mobile memory stick, take that, and put it into our processing computer. Okay, I'm on our desktop for our processing computer right now. I'm loading up FigSpec Studio, which requires you to log in with a username and password with an internet connection. Usernames and passwords are provided by FigSpec, and if there's any issue with logging in, they can assist with that, but keep in mind an internet connection will be required. Once I'm logged into the correct profile, I can easily load up my data capture. As you can see here, we did a quick single image of a river with a small land cropping popping into the center of it. In this main screen, we can just do some basic manipulation just to check out the image before we do processing, including you can determine if we're getting correct data from our data capture. You can see I've identified 3 water sources, which are roughly the same, and now I'm checking some vegetation sources, all of which are still roughly the same. Obviously a few variances here and there depending on the location and the material, but for the most part everything is what we're looking for in terms of what the spectrum actually looks like when we start to review it. Now you'll notice that I have done one area, and you can see the area itself is far less jagged in terms of the spectral line that has been created. So when you do an area, instead of just a simple point, your data is an average and the curve becomes far smoother, which is what we're trying to demonstrate with that. Now, because there is quite a lot of data, and this payload captures data one line of pixels to the next line of pixels in order, quite often your information will have to be cropped. That's one of the most useful tools in the FigSpec studio, and we're demonstrating that right now. Pretty simple. When you load up the information, the system will ask you to confirm which channel wavelengths you would like to keep or which bands you would like to keep. Then you just pick a graphical location to crop, and then you can crop that data. And we're showing it now on screen. You can see now we have a good cropped location for this river that we want to check out. It's not a deep river, but for our quick demonstration purposes, we can easily see that we have a nice grayscale image and a RGB preview image as well that we can work with and collect some data and do some basic processing. So let's start off with doing some processing. We won't go through everything. We're not going to go through, for example, water analysis. So instead, let's just do some basic processing so you can see what the system is capable of. You've already seen the number of algorithms in the grayscale processing module that you can action. Right now we're doing edge detection, which we can obviously adjust the parameters, get a lot more information, a lot less information depending on what we require. And once we're actually done this, we can save an image of our processed data for any reports or announcements or anything that you need to actually use that information for. But we can do high pass, we can do low pass, resolution filters, all of those were demonstrated. We can also do some exponential calculations. So you can see every time I'm pulling my cropped image in, so it's easier for me to work with. And then I can select the spectrums I want to work with. I can select any of these and set thresholds, but for the purposes of this video, I will leave the red, green, and blue spectrum channels as a default, and I will leave the thresholds as a default. So I won't be doing a lot of processing, but I'm just trying to show you what this system can do. Now, in exponential calculations, there are a number of indexes that have been preloaded. So here's a standard NDVI index for checking plant health, and as you can see, we run that algorithm and we get the output, which we can save as, first off, I'm saving it as a JPEG so that if I had to do a report based on this information, here we go. Here is an image of the particular spectrums that I reviewed using the NDVI index. And then also I can save all of this information as the index calculations, so I can get that information separately in terms of a .csv file, which I will show in a second. I'm just quickly going through all of the indexes, looking for the water stress index. So we'll just quickly run a water stress calculation on our data and just show you the output. So you can see it processed pretty quickly. Now I will admit I'm running on a pretty hefty laptop, so it's not that long of a process for this computer. Your processing time will vary, but you can see that I'm also saving the actual numeric results of our data processing. And I'll just quickly go and show that to you right now within the file folder that we're working on for this. So here's our water stress index results, which you can take and use for however you plan to use these results. So you can see we have the water stress index information in numerical form ready for you to go for however you want to use your results. You can also do this for all the other calculations as well. And quickly before we move on, I'll just show you the quality of the images that we would save for reports and such, so you can show those to other decision makers or the public or whoever you have to show them to. You can save them as JPEGs, PNGs, pretty much any video format. Now, before we end this video, let's just quickly do a little bit of reflectance correction. We won't go through the entire process. I'm not going to waste everyone's time sitting here while the system processes that data, but we can at least line it up. Quickly, just before we move on, here is the quality of data versus a water mixture from the spectral database of the American government. So you can see we are close. It's not identical, but keep in mind this is a system that's far less expensive than the satellite and can be launched and used for data collection on days when there is no satellite coverage available because you don't have satellite time or there's just too much cloud cover or whatever the reason. So it is near on demand. This is pretty much all the process I'm going to show you. Whatever you are capturing, when you want to do your reflectance correction calculations, all you have to do is highlight whatever you want to be your reference point for the corrections. Ideally, this would be your cloth panel that we showed earlier in the video, but in reality, you can use anything that you know the corrections for. I'm just demonstrating some water here from the river. It's not a very deep river, so the information we get would not be extremely useful in a practical aspect, but once again, for the point of this video, it should be enough to show you. And then once I have picked that point, I will quickly navigate to my corrections, which you would already have ready to go, and I do the processing. Now, none of the points are being shown in the right side of the screen because the corrections I quickly tossed together just so I could show you this are outside the scope of this graph, so they're far higher up, so they're not being represented in this video, but ideally you would take the time to create a proper corrections. But that process is something that we can also discuss with our sales staff and our technical staff and the manufacturer of the payload when our customers have trouble getting to these points or actioning these processes. But that is a quick overview of the Hyperspectral camera from FigSpec. It is by no means a total review of the system, but it should be enough to give you an idea of what's involved, the processing that you can do with it, and that is something we can always discuss in more detail if you contact the people at this email address. Thank you.